Hey geometry students, we are working into one of our hardest sections here, but I want to take a moment here and pause. Well, first off, how you doing? I hope you're doing well. I do need to take a look at one of the videos last week for 11.5 for Friday had one has currently one view, okay? So I have 20 students. You do the math. Okay, so I'm trying to keep this simple, but I don't know if there's too much Fortnites. I said it wrong on purpose. Going on Friday for the gentlemen and ladies. I mean, I don't know what you guys do, but guys, this is super important, and I'm trying to bring it down. If we're going too fast, just let me know. Plan for this week is Monday, 11/6. We'll probably spend 2 days on this. We'll see. Okay, we'll see. Yeah, we'll spend 2 days on this. I'll probably stretch it out. So please work the problems. Please look at the video and work the problems. We got Good Friday, and then we have one more section, and then we'll take a chapter 11 test, and then we'll be over. So yeah. So let's get started. This is one of the more challenging sections. Let me set it up. Okay, well actually I'm going to take my camera here and read. Look at this section. Look at that. Okay, so read about the apothem, read about the center of the polygon, etc. Okay, and then that's really our theorem right there. Okay, so we're interested in different shapes, but notice the word regular. Remember what the word regular means in regards to a polygon. Okay, so that's what we're going to do, find areas of regular polygons. Okay. Let me set this back up. Pause. Okay, so I drew this with this because, you know, I have to make myself feel better. I'm all about making myself feel better. Okay. All right, so nice happy circle here. Here is something that we're used to taking the area of, okay, a triangle. Now, typically with the triangle, we're like, hey, we want to find the area of a triangle, and it's 1/2 base times height. Well, now we're in a different scenario, okay? I'm jumping ahead. I'm jumping to the end here, and I want to find the area of the shaded region. Okay, so I know that you know how to do that. Typically, okay, so area shaded, shaded, okay, is going to be the area of the circle, which we just did, minus the area of the triangle. Okay, so area circle, okay, minus area of the triangle. Alright, so we can do the circle. Wait, no we can't. Oh, yes we can, because the apothem in this case is the radius of the circle. Okay, so the area of the circle is pretty easy. Okay, area equals pi r squared. So the area of the circle is just going to be pi times r squared. Okay, in this case it's 10, so area times 10 squared. Or, excuse me, not area, pi times 10 squared. Alright? Well, the area of the triangle, we don't have base and we don't have height. We have this new formula that's called 1/2 AP. Okay? P here stands for perimeter and A stands for apothem. Okay? It is the height from the center out to the corresponding vertex. Okay? From the center, whoop, no it's not. Whoops, I knew that was wrong when I said it. I was like, wait a second. Reading the text here, well, you can read the text, the apothem, okay? So, it is, well, I want to read it. So, the distance from the center to any side of the polygon is called the apothem. So, from the center to any side. Center to any side. Well, not just center to any side, okay? Center that splits it, okay? It is gonna make this congruent here, okay? So it's got to be a height, okay? Yeah, if you read the full definition, it does give this component, okay? So, again, so from the center to there, splitting the sides in half. This is key to solving for the apothem, okay? So we have the radius, which they gave us, all right? And that's helpful for getting for the circle. But that doesn't help us find the apothem. Nor, so if you look at this, 1/2 P for perimeter, ANS, well, A we know, that's the apothem. well, we don't know its value yet. N stands for number of sides, okay? That's why perimeter of a regular polygon is just going to be the side length multiplied by the number of sides. So if it's a pentagon, okay, and the side length is 5, then it's going to be 5 times 5, because it's 5 sides and side length of 5, okay? I'd rather use A and S because that way I get the parts. So S stands for side length. Side length. Okay? So side length. All right. So if we have to find the side length, we have to find the apothem. Okay? We know the number of sides. 1, 2, 3. Okay? So I know the number of sides here is 3. How in the world am I going to find the apothem and the side lengths? Well, hopefully, first off, you can see that this here is going to form an isosceles triangle. Okay, that's helpful, possibly. Okay, but more helpful is the fact that this triangle here is a right triangle. Okay. Okay, so I like to take the triangle in question and blow it up and move it down here. Okay, because again, I need x. I actually want the whole side length, but this is going to be doubled. So if I find x, which is this length here, I just double it, and then I have the side length. Okay, I still need the apothem. Okay, I need both. So how do I do this? Well, I know that this is a regular polygon, and that the sum of interior angles adds up to 180. All right, divided by 3 because they're all congruent. So then each of these are 60 degrees. Okay. Well, this splits this. Okay, this splits this down the middle. Okay, that's what this does. So we can put these congruency symbols here. So if this whole thing is 60, then this is going to be 30 degrees. Okay, theta is the symbol often used for angles. Okay, so now I'm going to use trig functions, set those up. Okay, so just simple trig function, sine of 30 opposite over hypotenuse, and cosine adjacent over hypotenuse, solving for each individually. The apothem then is 5. X is 8.7. I want to multiply. I'm going to use multiply by 2. Okay, times 2. 17.3 is going to give me the total side length. Okay, so going back to this, the total side length is 17.3. The apothem is 5. Okay. And so then we have everything we need. So going back to what we were looking for, we wanted the area of the shaded region, area of the circle, minus the area of the triangle, 1/2 A, N, and S is going to be 17.33. Okay, so plugging that in, with my calculator, got this, 1/2, 5 times 3 times 17.32. I said 33, but 32. Subtracting the 2, and we get 184.3 units squared. What is something to note here, I want to bring a sidebar down here. Typically we like to use 1/2 base times height for a triangle. I want to just show that 1/2 A and S works the same way. So 1/2 times the side length, 17.32. The height of this triangle would be 5 plus the 10 here, be 15. So this times this times this gives me 129. So don't use this one here if you're doing the apothem and stuff, but I'm just showing you that the areas will come out the same. So let's do another shape because I want a different one. Okay, so got my colors here. We need to find the apothem. We also need the radius because if you look, we have radius squared, but we don't have the radius. We know the number of sides, 5, okay? We don't know the apothem. We do know the side length, okay? So we do know that. So that's about all we know. I'm going to work this one a little bit differently. Earlier, the one I did before, I used the fact of sum of interior angles. And you could do that too, sum of interior angles of all these and split them in half. But I'm going to do a different trick, okay? I'm going to use the fact that all of these angles add up to 360, okay? So this one, plus this one, plus this one, plus this one, plus this one. So all 5 of these triangles, not counting this one, so the big triangle, this triangle, this triangle, this triangle, this triangle, that come from the vertices, okay, they all add up to 360. How do I know this? They make a circle, okay? So 360 divided by 5 is going to be 72 degrees. Okay, so that's helpful. So that means this whole thing here is 72 degrees. Okay, but the trick to all these is just pause and blow things up. Not like with a grenade or something, but take a small section and take it out. Okay, so I'm going to take this triangle out and write it over here. So this one right here, because I need to focus on the individual parts. Okay, so here's my scenario. I've got this. I know this is 72 degrees. Okay, this whole thing here. And then I'm going to take this triangle here and put all the parts. I need R and I need A. And I know that's 36 degrees. Again, how? Well, remember the Potham, okay, splits this, and so it'd make this angle here congruent to that angle there. So 72 divided by 2, 72 divided by 2 equals 36 degrees. Okay, so I'm going to go ahead and set up my trig functions. So I've got, I'm looking for A. In this case, it's going to be opposite and adjacent. Okay, that's tangent. And this one's going to be opposite and hypotenuse, and that's going to be sine. Okay, so again, in reference to this angle 36, opposite over adjacent. Okay, tangent 36 is 5 over A. Solving for A gives me 6.9. And then sine, opposite over hypotenuse. Set that up, solve for R, gives me 8.5. Now I have everything I need. Okay, so again, area of the circle minus area of the pentagon. Okay, pi times R. We had to get R by breaking this into smaller pieces. Okay, we were given the side length. Okay, and so then I just drew to the center. I knew that all of these angles add up to 360, and so then I took 360 divided by 72, and I take a sliver of the triangle. So most of these you're going to take the sliver of the half of the half, if you will. You're going to break each of these into quadrants, if you will, and then take the half of the half. Very similar to the triangle we just did with the other one. Okay, solve for the apothegm, solve for the radius, and going back to this, 1/2 A N S, subtract the 2, and I believe is what, 54.5 according to my calculator, units squared. Answer done. Okay, so these are two tough ones. For homework, I'll probably do one separate where you just find the area, and then I'm going to try to throw in, you know, one like this, because the area of the shaded region is kind of fun. I like it. So don't hesitate to email. Don't hesitate to ask questions. Guys, view the videos. We have an upcoming test. We have one more section to do after this, and then Chapter 11 test is done, and we're going to build on that for Chapter 12. So basically, we're going to take something like this with Chapter 12, but where this would be the base, and we're trying to find the volume or surface area, okay, of a three-dimensional figure that might be a pentagonal prism. Okay. All right, I'm going to stop rambling here, and may the Lord bless you and keep you. All right.